Okay, we are going to work on solving systems of equations. So in the first semester, we should have worked on solving equations. We should have worked on graphing equations. Now what we're going to do is essentially the exact same thing, but we're going to be solving and graphing two different equations essentially at the exact same time. Okay, so we will be, probably need to know what a system is. So, by the end of today, you should be able to know what a solution is and check your solution. You're going to be able to solve systems by the graphing method. That's our only focus today is graphing method. And then we're going to use systems to solve real life problems, basically our word problem objective today. Okay. A system of equations is two or more linear equations in the same variables. Here's an example of one. X plus y equals 7 and 2x minus 3y equals negative 11. Here's the first equation. Here's the second equation. Together, they're a system. Okay. First thing we want to identify is what is a solution. A solution of a system of linear equations in two variables is an ordered pair that is a solution to each equation in the system. Anybody remember how we determined whether something was a solution or not in the first semester? How could I tell if like X was a solution to something? What if I told you I knew X was equal to 5 and you had a variable that was an X inside your equation? Probably been doing it for a handful of years. What do you do if you know what X is equal to and you have a variable that's X? You can times it, but in this situation, not always the case. No, that's how you solve. I'm telling you, you know X is 5 or 10, it doesn't matter, and you have a variable with an X. You can plug it in, and that's all you're going to do to check whether something's a solution. Okay, so we're going to try to identify something as a solution or not. Assuming it will focus. Okay, so here is our system. Top one is X plus 7 or X plus Y equals 7. Bottom one is 2X minus 3Y equals negative 11. I want to check, is the ordered pair 2, 5 a solution? First thing you need to identify is what's your X value and what's your Y value. So based on this ordered pair right there, what's my X equal to? What's my Y value equal to? 5. First number's X, second number's Y. So now I'm going to take that top equation and I'm going to check if it balances out. Instead of X, what number can I write? 2. This is plugging it in. Plus Y, but what's Y? 2 plus 5 is? Did it balance out? Yes, it is. So this is a solution. So the ordered pair 2, 5 is a solution to the top one. We're good. But for it to be a solution to the system, it has to be a solution to the top and also solution to the bottom one. So now we just have to check the bottom one. Same thing, just with the bottom equation. 2x minus 3y equals negative 11. Okay. 2x. So when I have 2x, that means 2 what x? Times 2. That's how you would solve. But this one, we're not solving anything. We're just plugging in and checking. So what number is going to replace x, though? What number is replacing x? 2. And what number is replacing y? 5. The same 2 and the same 5. 2 times 2 is? 3 times 5 is? 4 minus 15 is? Did it balance out? Sure did. So is it a solution to the bottom one? Yes, it is. Is it a solution to the system? Yes, it is. It's a solution to the system indeed. Has to be true to the top and true to the bottom. Okay, if you get any one of them that's not a solution, game over. It's not a solution to the system. Okay, so B is going to be the exact same thing, just the numbers are different. Somebody have what my X value is going to equal. What about my Y value? All right, what number is going to replace Y here? 0. What number is going to replace X? -2. And now I just simplify. Zero is equal to, anybody happen to know what -2 times -2 is? +4. And then 4 minus 4? Did it balance out? Sure did. Is it a solution to the top one? Sure is. And now we're going to do the exact same thing, but to the bottom one. Okay, so I'm even going to draw a little line here. So we have Y equals X plus 4. What number replaces Y? What number replaces X? -2 plus 4? 2. Did this one balance out? So is it a solution to the bottom one? No. So is it a solution to the bottom or to the system? Okay. All right, so all we just did now is we just tried to identify something as being a solution or not being a solution, okay? Realistically, we just need to establish we know what a solution is so we can actually do the next part here. We're not going to do them right now, but if you happen to want to check to see if something is a solution or is not a solution, you have these two bottom ones. I'm not going to show the work, but this one is not a solution, and this one is a solution. So if you wanted to end up just checking those two on your own, if you do a little practice, that's where your answers are. All right, let's go to the next page. Now what's really going to end up happening is what we're going to be doing is we're going to be given the system and it's going to be our job to find the solution. So in the first example, we were given the solution. We just had to verify that it was indeed a solution. Now what we're going to do is we're going to be given the system. We have to find the solutions itself. Okay. So this is a great example of what a problem is going to look like. So when you take your learning target problems, hopefully today, if not next time, this is kind of what your problem is going to look like. So what we really need to do is we need to remember how to graph. Okay, so to be able to do that, I have to give us a little reminder of our two main methods. So right up here in the upper left corner, I'm going to give us a little reminder. We kind of have two methods. Within those methods, there's actually kind of three routes. Okay, the first option is when it's in this form, y equals mx plus b. I would say the vast majority of our problems are going to be like this one. Okay, in slope-intercept form, y equals mx plus b. And when you do that, you have to find two values. Does anybody remember what those two values are? M value and b value. More importantly, does anybody remember what the m value represents? Slope, and the b value represents y-intercept, which is the starting point. Okay. Okay. And we'll go over exactly how to graph all three of these. I'm just kind of giving you a little route of the three different options here. The second option is the X and the Y are on the same side. AX plus BY equals C. That's called standard form. Okay. And within these, there are two options. Your first option is if it's like this, you can solve for Y, because if you solve for Y, it's going to be exactly like method 1. Okay, and sometimes that's beneficial. Okay, method 2 is to find the x-intercept and the y-intercept. So those are, it's kind of like 3 options, but like number 2 just has 2 different routes you can go. Okay, and I will show you all of these options today in 2 examples. So as I look at example 2, I look at this first one here. Is this looking like a method 1 problem or a method 2 problem? 1, because the y is by itself. Okay. So what I'm going to do is I am going to graph this one. I'm going to refer to this as the black equation. Okay. It's in this form. It's in this method. This is what it looks like. And I need to find my M value and my B value. Anybody think they have either of those? Okay. B is 5. You got the other one then? Okay. Does anybody remember? We actually wrote one of these 2 as a fraction typically. Does anybody remember which one of those 2 you write as a fraction? The slope, which is the M. How do I write a whole number as a fraction? And yeah, and it will always just be over 1. If it's already a fraction, you don't have to really worry about that. Let's do a little side note with slope. Trying to cram as much from the first semester as I can in between here. Okay, when I have a slope, top number is going to tell you one of 2 different directions. Up or down. Yep, up or down. How do I tell if it's up or if it's down? Positive or negative? Which one's positive? Positive is up, and then therefore negative is. So if the top tells me up or down, the bottom's going to tell me left or right. Left tells me what direction. Or I mean, yeah, negative will tell me left. You guys knew what I was asking. Negative will tell me left. And positive will tell me right. So kind of using this, as I look at my slope of negative 2 over 1, negative 2 on the top, where's that tell me? Down 2, right. And then positive 1 on the bottom is right 1. Okay, I think we're 100% ready to start graphing now. Okay, so remember, you start with the B value. Okay, so we're going to start with the B value. Okay, and so I'm going to start with 5 on the y-axis. 1, 2, 3, 4, 5. And where does the slope tell me to go from here? Down 2, right 1. Now, I think for the vast majority of us, we get it when you say over 1. But I like to be specific and say use descripting words like left or right. It's going to tell me down to right one specifically. Okay, that is the first line. Any questions about the first line? We spent a lot of time doing this. I do want to essentially reteach it to you so you have the opportunity if you missed it or forgot it. Now, I do know that you spent most of Christmas break doing this for fun on the side, but, you know, maybe in that one day off that you took over break from math that, yeah. I know he was doing this every other day. Yeah, he's going crazy. He's got worksheets full of this stuff at home. Okay, ready? Let's do this. All right, let's do the second one. Okay, I'm going to refer to this one as the red one. Okay, what form is it in? Yep, y equals mx plus b. So that means y is equal to 4x minus 1. So I have to find that m value and that b value. Anybody got either of those? Actually, b is not 1. B is -1. Good. And 4 over 1 tells me specifically what? And right one. I like using the word right instead of over. Where do I start? Nope. That b value is your starting point. Notice I put start here for both of them. Okay, so I'm going to start at -1 on the y-axis. It's always going to start on the y-axis for these. And from that point, I do what? Up 1, 2, 3, 4, right 1. 1, 2, 3, 4, right 1. 1, 2, 3. I'm out of space. Does anybody remember how to go backwards from up 4, right 1?
Down 4, left 1.
Yep, you just reverse the direction. Down 4, 1, 2, 3, 4, 1. Down 1, 2, 3, 4, left 1. I don't know about you all, and I know that you all love this class more than life itself, but I can tell you, I don't know how you look at that and just don't say, that looks good. That looks real nice.
That looks good.
It looks real nice. Looks beautiful. Okay. All right, so let's try to figure out what our answer is. Okay, so on the red line, every single little blotch of ink is a solution to the red line. On the black line, every single little blotch of ink is a solution to the black line. I want to know, where is the spot that's a solution to the black and the red line at the same time? 1, 3. And how did you know that? It's where they intersect. X value 1, Y value 1, 2, 3. That's my answer. Okay. Okay. Real quick, what I am going to show you here, I'm actually going to skip this step entirely because it's optional. I have very few students do this. But if you wanted to, what we just did on the front page, you could technically take X is 1 and Y is 3 and plug it into both the black and the red equation. And as you can see here, they balance out, and then you know your answer is a solution for sure. Or you just really know how to graph and just lean on that. Okay. Okay, so now at this point, what we're going to do is everybody should have some graph paper. I'm going to do number 5 in the monitoring progress with you together because those ones are not in y equals mx plus b form. Okay, so I'm going to do number 5 in the monitoring progress at the bottom of that page. Okay, so I'm going to do that right now with everybody together. Okay, let's get started. Okay, so it's the same sort of thing, but the difference is the y by itself on neither of these. So I'm going to show you the two options you have. I'm going to show you the two options that you have when the y is not by itself. And I'm going to start with finding the x-intercept and the y-intercept. Okay, I'm going to refer to this top one as the black equation. Okay, and then I am going to find the x and the y-intercept. X-intercept for the top one. If you were in my class in the first semester and you don't remember this fact, I'm going to be quite disappointed in you, because there should be a very important fact about the x-intercept that everybody should know, because I talked about it a lot. Y equals 0. So if you're finding the x-intercept, it's just a fact. The y value is 0. So if the y value is 0, what variable goes away? Y. So all that's left is just the x part. And how do I solve for x? Divide by 2. I got to divide by 2. 5 divided by 2 is 2.5. So what's my x-intercept? 2.5. So what I can do is I can take the x-axis and I can find the number 2.5. X is 1, 2.5. Okay. Well, I found the x-intercept. I might as well find the y-intercept. Okay. X-intercept, fact everybody here has memorized. Y is 0. If I'm finding the y-intercept, what's the fact everybody should have memorized? X is 0. So what variable goes away? X. So what's left over? Y equals 5. I don't even have to do any work. I just know what the y-intercept is now. What's the y-intercept? Once I have those 2 points, I can actually just connect them in a straight line. No, I have the straightest hand. I can write straight lines better than anybody.
Do you want a circle
I can do okay. We'll check after.
though?
Square? No way. Terrible at those.
Oval. Straight line, you draw square.
Accurate. But can you draw them at a 90-degree angle? If you have 4 straight lines, that might not be a square, because you have to draw them at a right angle. Yeah. All right, ready? Okay. All right, let's do the second part. Okay, second part here. What I'm going to do is I am going to show you how your second method, you can solve for y and also graph that. So if the x and y are on the same side, you have 2 options. Because sometimes the x-intercept method isn't that great, or x-intercept y, because sometimes you get decimals, and decimals are harder to graph than the whole numbers. Okay, so what I'm going to do is I'm going to take 3x minus 2y equals 4. And I'm going to solve for y. Okay, if I'm going to solve for y, that means I need to first get negative 2y all by itself. Yeah, I'm going to minus 3. So I'm going to look here. Okay, just face the front, please. Okay. Okay, so I have a 3x. I'm going to ask myself, is that a positive 3x or a negative 3x? Positive. How do I cancel out positive 3x? So I'm going to minus 3x from both sides. Some people already have that. Can I take 4 minus 3x and get 1x? No, because they're not like terms. Okay, side conversations need to end. Okay. I know that this is a +4 and not a -4 because this is a +4. Okay, how do I solve for y here? Nope, not adding 2.
Divide.
Divide by -2. And then I'm left with y is equal to. Anybody knows what happens when I take a negative divided by a negative?
It becomes positive.
Becomes positive. So this is a positive. 3 divided by 2 is 3/2. And then +4 divided by -2. -2. Now that the y is by itself, it's in slope intercept form. So what's my m value? Okay, 3 on the top tells me which direction. Not down 3. Up 3, right 2. And what's my y-intercept? Nope.
-2.
-2. Stop. Okay. So from this point, I have my y-intercept. I'm going to go up 3, right 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. And you can do this forever. We actually already found the intersecting point, right? And then I can connect these. Naughty. Okay, and then the next thing I need to do is find the solution. Okay, the solution is right where they meet, right here. The x value here, 0, 1, 2. So x value is 2. And y value is 1. Okay, so now I've gone over all the 3 different options you can do when graphing. Those are all of them. An exhaustive list. This is what I want everybody to do. On these graphs that you have, what I want everybody to do is just with somebody next to you, one person do monitoring progress 3, one person do monitoring progress 4, and then when you're done, you can like just cheat off each other, or you can just check the other person's work. Okay, real quick before you start, what's the number multiplied by the x here? What's the coefficient? What's the number multiplied by x here?
0.
No. 1. What's the number multiplied by the x here? -1. Okay, so let's spend about 5-ish minutes doing that. One person do 3, one person do 4.
You're right. I did that wrong.
Okay,
Right, I did that wrong. I was going
here's your first one.
up 3, not 9.
First one, y equals x minus 2. Again, when x is just, that's a 1x. So that's a 1 over 1. That's up 1, right 1.
Yeah.
Okay. Okay, so we're going to start at -2, and we're going to go up 1, right 1. Bottom one, we're going to start at 4, and we're going to go down 1, right 1. So we get to this intersection point of 3, 1. Okay, number 4. Okay, number 4, what we're going to do is the same thing. Your slope is 1/2 and your b value is 3. So we're going to start at 3 and we're going to go up 1, right 1, up 1, right 1, up 1, right 1. Okay, now the bottom one, I did have a couple people ask me questions. Are both numbers negative? No, either the 3 is negative or the 2 is negative. And it actually doesn't matter which one you pick. You just have to pick one of the two. So if there's a negative out front, just one of the two is negative. So we're going to start at -5 and go down 3, right 2. But when I'm going down 3, right 2, I'm realizing I'm never going to cross that black line going to the right. So I'm going to go backwards, up 3, left 2, up 3, left 2, up 3, left 2. And then now I've ran into that intersection point. That intersection point is 4 to the left of the origin and 1 above the origin. So that's an ordered pair, -4, 1. Okay. Let's go to the word problem. That'll be the last thing for the day. And then it's practice time.
With my case, the paper.
Okay. A roofing contractor buys 30 bundles. Roofing contractor buys 30 bundles of shingles and 4 rolls of roofing paper for $1,040. In a second purchase, but you're paying the same prices for each of those, contractor buys 8 bundles of shingles and for $256. We're going to find the price per bundle of shingle and the price per roll of rolling roofing paper. I can't speak. Okay, so this question or the request from the problem is what the variables mean. I don't know what the price per bundle is, and I don't know what the price per roll is. That's what I'm going to find out. So I'm going to write 2 equations. The first is going to discuss the first purchase. In the first purchase, how much money was spent? $1,040. So B is the price per bundle, the price for one bundle. How many bundles were purchased? 30. Okay, so how many, so how can I represent purchasing 30 of them? 30B. Plus R represents the price for one roll, and I purchased 4. How do I represent that? 4R. And I'm adding them together because I would take my money from bundles plus my money from rolls, and all together that's $1,040. If this was a test question, you'd be at 2 out of 4 points. There's 2 equations to write. You wrote one of them successfully. Okay, now we want to discuss the second purchase. In the second purchase, how much money was spent? With the 256, that was made up of 8 bundles. Okay, so 8 bundles. How can I represent that? 8B. Okay. If this was a test question, you'd be at 3 out of 4 points. You wrote both equations accurately. Okay. All right. So now what we're going to do is work on graphing. Okay. It's in standard form, so I'm going to find my b-intercept and my r-intercept. Yeah. Probably because she was not here when I took attendance, so I haven't fixed it yet. Okay. All right. So what I want to do is I want to then find the b-intercept. So similar to the x-intercept and y-intercept, if I'm finding the b-intercept, the r value will be 0. So then what variable goes away? Okay. And how do I solve for b? Divide by 3. I'm going to get decimal. In fact, I'm going to get 34.7. Well, I'm rounding, but 34 and 2/3, but I'm rounding that 2/3 up to 0.7. Okay, so if I'm finding the b-intercept, r would be 0. If I'm finding the r-intercept, b would be 0. And then what variable would go away? And that would be 4r. And then I would divide by 4. And when I divide that by 4, 1040 divided by 4 is 216. So now I know what my b and r intercept are for the first one. Now I'm going to find the b-intercept and the r-intercept of what I'm going to call the red equation. I actually think the r-intercept is going to be easiest because there's no r variable. There's no r variable. There's no r-intercept. There is none. B-intercept, that means r is equal to 0. Well, there's no r variable anyway. So all that's left is 256 is equal to 8b. And then I would divide by 8. Find that the b-intercept for the red one is going to be 32. All right. So we have all the tools we need to be able to graph this. Let's actually try to graph it now. All right, so I'm going to trace some axes here. I did some counting in the previous class. And this bottom axis has 30 slots. So this is going to be the R axis for me. And this has 40 slots. So this is going to be the B axis for me. So we're going to do the black line first. We need to figure out what to go by. I need to get to 260 on this axis, and we know that there's 30 spots. It's a reasonable number I could go by to get to that 260 at least.
And
10. If I go to 10, this will be 300. And that means 260 is going to be on there fairly nice and neat. I think that's great. Now, you don't have to mark each of these as 10, 20, 30. What you can do is this. You can kind of cheat. 0, 10, 20, 30, 40, 50. 60, 70, 80, 90, 100. 110, 20, 30, 40, 50. 60, 70, 80, 90, 200. 2, 10, 20, 30, 40, 50. 60, 70, 80, 90, 300. Okay, on the B axis, I know I need to get to at least 35. And there's 40 slots there for me. So what can I go by? 2. If I go by 2, I'd be at 80 at the top. So don't overthink it. 5. If I get to 5, I will be at 200 at the top. 10, I'll be at 400 at the top. We only need to get to right around 35. Ones would be great. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, or 1, 2, 3, 4, 5. I miscounted. 1, 2, 3, 4, 5, 6, 7, 8, 16, 17, 18, 19, I guess there's only 39 slots. Maybe I miscounted the other class. That's fine. All right. So now that we have everything kind of numbered out, I have to do a R axis of 260. So I'm going to go down here. Here's 250. And they're each 10. So 260 would just be the next one over. It's right here. Okay. My B intercept would be 34.7, which is just a hair under 35. So let's just say right there. And then hopefully my straight edge is close enough to connect them. And that's the black line. The next thing I need to do is number 3, or the red line. No R intercept, but there is a B intercept of 32. So here's 30, 31, 32. How am I going to draw that line in a way that there's no B intercept or no R intercept? Well, straight up and down. So if I go straight up and down, it's crossing the R intercept right here. Straight left and right. It's going to be a horizontal line. Okay, and then I have to find the intersecting point, which is right here. So it looks like 10, 20. So it means R here is 20. And B here is 32. So how much does a roll cost? Nope. Roll is going to be 20 bucks. Right? Because that R value is 20 down here. And then a bundle costs what? 32. And that's what a 4 out of 4. Okay, practice. These are your practice problems before you take your learning target, number 9 through 20, 27, and 28. Okay, 28 is a word problem. It's almost the exact same thing as your learning target word problem. So you're going to have one regular graphing problem and a word problem. So if I'm you, you could pick either of these. If I were you, I would pick 28. Okay, to be able to take your learning target, you needed to take one problem from here and one of the word problems minimum before you practice or before you take the learning target. Okay. All right, so at this point,